Welcome to the notes on area, but this time we're going to be finding the missing sides before we can find that area. So we're going to be doing rectangles, parallelograms, triangles, and trapezoids again. So there we go. Find the area of basic shapes by finding missing dimensions first, okay? Base does not mean bottom. We talked about that. And then this is the key idea. Base and height are always perpendicular. Again, makes that 90-degree angle. Again, base does not mean bottom. I know you've probably heard that before, but get that out of your head. So determine the area of the following figures. So it's a rectangle. So we know area is base times height. Okay, so we've got a height. We got this 15, but this is going to be perpendicular to this piece right here, but we don't know what this is. Well, luckily for us, we have this right triangle here. So if I kind of redrew that separate right here, if I just redrew it on the side, I've got a right triangle with an unknown side. So I'm just going to use Pythagorean's theorem. All right. So you guys remember leg squared plus leg squared equals, all right, hypotenuse squared. When I solve for that, all right, you should end up with x equals 12. You guys know how to do Pythagorean theorem. So I'm going to skip that that step. Once I know that x is 12, I know a base in my height. So area equals 12 times 9. So my final answer then is 108, and that's feet squared. So that's how you do the rectangle. This next example over here, right? Another triangle problem. Now again, it's the triangle. It looks like we've got a base and some kind of a height, but no, remember base and height need to be perpendicular. So this is actually our base and our height here. So that's where you got to get out of that mindset that base is on the bottom. So a lot of people just want to say it's 60 divided by 2. No, all right? We need to find this piece right here. So Pythagorean theorem, again, is 6 squared plus x squared equals the hypotenuse squared. When you solve for x, okay, when you solve for x, you should get 8. All right, you guys know how to do that. Subtract the 6 squared from each side, square root, x equals 8. Once I know that this piece is 8, that is our base and the height. So area is going to equal 6 times 8, and all that's divided by 2. So 6 times 8, 48, divided by 2 is 24 square feet. So there's the answer to that problem, right? Again, tough problem. Don't just think the base is on the bottom. Another triangle, okay? Again, we got a 10, we got a 15, okay, but base and height are perpendicular. So I need this piece right here, this height. Okay, so now we can't use Pythagorean theorem, but what I can use is I've got a right triangle. I can use a little SOHCAHTOA, a little trig action. So I'm going to redraw that triangle on the side here so you guys can see it. Here's my 42. I want to find this height. I know this value of 10. All right, I can use trig. This right here would be my opposite side. This right here is my hypotenuse. So which one involves opposite hypotenuse? It's sine. So I'm going to go sine of 42 equals opposite, which is, I'm going to call it my height, over the hypotenuse, which is 10. Remember, when you do this, you just cross multiply. So I'll get my height will equal sine 42 times 10 is approximately 6.7. Once I know my height 6.7, now I can solve for the triangle because you just need the base times the height. So area equals the base, we're going to call 15, times that height of 6.7. We're going to divide that by 2. And when we do that, we should get 50.2 centimeters squared, or squared centimeters. So there is our answer. Last one, trapezoid problem. All right, base 1 plus base 2 times the height. Looks like we got a height here. We've got a base 1, but we need this piece right here. So how are we going to find that piece? Well, we know, if I'm going to redraw some lines, we know from here to here is 10. Okay, so what I really need to find then is just this piece right here. Well, again, I've got a right triangle. This right here is the 12, the same as this value right down here. So got to find this. Again, another Pythagorean theorem problem. So when I set this up, it's going to, I'll do it right on the side. I'm going to have my x squared plus 12 squared equals 13 squared. If I solve that correctly, I should get x equals 5. So this value right here is 5. And since this is 10, this one right here is 10, this whole distance, now be careful, 5 isn't my answer, this whole distance is 15. So that's what that second base is. So when I erase all the markings I've made, I've got my base 1, I got my base 2, and I got my height. This 13 We really don't need to find the area. We just needed it to find that missing piece. So area equals base 1, 10, plus base 2, which is 15, all right, times the height, which is 12, divided by 2. When you do all that, your final answer should be, you'll get the area equals 10 times 2, I think it's 100, so 10 plus 15 is 25. 25 times 6 is 150 square feet. And that's how you find area, by finding a missing side length first. Equilateral triangles, I just want to show you guys this. We know that all the sides are 6. Well, the height for these, you're going to draw the height right down the middle. When you draw that, all right, that'll actually bisect this side. So what you're going to end up with is you're going to end up with a right triangle right here where this is 6, this is 3, and this is x. You can use Pythagorean theorem to find it, and I'll call x actually the height. Use Pythagorean theorem to find that height, then you're going to plug it into the formula. So just knowing that it bisects is kind of the key idea with equilateral triangles. There is a formula, but I'm not going to have you guys worry about that quite yet. But that is our lesson on area, finding area by finding a missing side length first.